Well, hello, Precalculus students. Today we are going to be learning about parabolas, and so this past summer I went on a little road trip, took some pictures, tried to find some parabolas around the country, and so I took this wonderful picture. You might have seen this before of the St. Louis Arch, only to find out this is not a parabola. This is a shape called a catenary. Looks like a parabola, but not quite. Okay, so I kept on driving and I came to San Francisco, the Golden Gate Bridge. Took this wonderful picture. Turns out that this shape here is also not a parabola. It is also a catenary. So it's a little discouraged, drove home, came into school to work, walked down the hall. You might recognize this exact water fountain. This is a parabola. What makes this a parabola and not the other ones? Well, we're going to talk about that over the next couple of weeks. But today, oh, actually, I'll skip over that. Another place where you'll probably see parabolas is right here. So, gravitational pull will pull these objects like these angry birds, like water, downward, and anytime you have anything following this shape, you do have a parabolic shape. So let's talk about these. So we know that the graph of a quadratic function gives us a parabola. Well, what is a quadratic function? Well, a quadratic function is really any function that has an x squared term, or it could be a y squared, but normally we talk about quadratic functions being in this form. Y equals ax squared plus bx plus c. A, b, and c just stand for any number. The key is that we have y equals x squared in there. So if we graph something like this, and I'll just put a set of axes here, if we graph a function in this form, it'll always be this parabolic shape. So we'll always see some kind of curve such as this. And actually, if we can, I'm just going to shift that curve down a little bit because I'm going to talk about different intercepts that we will sometimes see. So on that curve, just want to label a few things. First of all, any shape, now we think of lines as having a y-intercept, but any shape that goes through the y-axis has a y-intercept. Now parabolas can have 0, 1, or 2 x-intercepts. And we're going to be talking a lot about those in the next couple weeks. This point here, and sometimes it's at the bottom, sometimes at the very top of a parabola, is called the vertex. And you'll notice on both sides of a parabola we have the exact same shape. This here is called the axis of symmetry. Okay, now, like I said before, this parabola could really open left or right as well, which would mean the axis would be flipped, the intercepts would be flipped. Most of what we're going to see will look like this, opening upward or opening downward, and that's if you have y equals x squared. If we had x equals y squared, the entire graph would be rotated 90 degrees. Okay, now the standard form, we've been talking about transformations lately, and it's really hard to transform this graph because of this x term. But if we can write this equation a little bit differently, like this, y equals a times x minus h squared plus k, then we can talk about this in the language of our transformations in the last unit. H and k will give some sort of, well, k will give a vertical shift, h will give a horizontal shift, a will interpret the vertical stretch of this graph. So in this case, your vertex, I'll skip down here, is going to be the point h comma k, because that is the amount of shift in the left, right, or up, down direction. The axis of symmetry is a vertical line, so it's going to be x equals some number, and the number is the x coordinate of the vertex. Now again, if this was x equals y squared, everything would be a little bit different, but what we're going to talk about for the most part are these quadratic functions of the form y equals x squared. Okay, so let's jump into examples. First example, identify the vertex, x-intercepts, y-intercept, and sketch the graph of this function. So here we have this quadratic function in this standard form. So since it's in standard form, we can jump right in and we can say, hey, we know the vertex is going to be defined by these horizontal and vertical stretches. Okay, the vertex is going to be what number you can plug in for x to make it equal 0 in those parentheses, so 5 comma, and then the number out here is going to be the vertical shift. So your vertex is going to be at the point 5 comma negative 4. Okay, so let's talk about these intercepts. So we know, if I just make a rough sketch of or if I just think about a parabola, we know that your x-intercept, and I'm just going to flip back here, your x-intercepts are points like 2 comma 0, 5 comma 0, 9 comma 0. So it's where the y value equals 0. So to find those x-intercepts, which went the wrong way, there we go. To find an x-intercept, we know that our point is going to be something comma 0. Okay, so what we do to find an x-intercept is we plug 0 in for y. So let's do that. So let's write this as 0 equals x minus 5 quantity squared minus 4. And then we can solve this for x. Okay, we'll add 4 to both sides. Then we can take the square root of both sides. That'll give us 2 equals x minus 5. Now, I'm just going to stop right here, because if we think about this, 2 squared equals 4, but also negative 2 squared. So just an algebraic tip to look out for. Anytime we take the square root of both sides to solve an equation, we could have a positive or a negative value for an answer. Okay, so that gives us two cases. We could either have 2 equals x minus 5 or negative 2 equals x minus 5. Either way, if you add 5 to both sides, we get 7 equals x, or if we add 5 to both sides here, we get 3 equals x. So our x-intercepts are at the points 7, comma 0, and also at 3, comma 0. Okay, so we've got our vertex, we've got our x-intercepts. Let's talk about our y-intercept. So y-intercept, thinking about your graph, and I'm going to flip back a page here. Y-intercept is a point like 0, 2, 0, 5, 0, so 0 comma something. So for your y-intercept, we always want to plug 0 in for x. Okay, so let's do that. This is actually a lot easier. We can probably do this in our head. So if we say 0 minus 5 is negative 5, square that, we get 25, minus 4, that's going to be 21. So y-intercept is usually much easier to find than your x-intercepts. Okay, so we've got our vertex, our x-intercepts, our y-intercept. Now we're ready to sketch this graph. So I'm going to get a couple axes. Our vertex is at 5, negative 4, so we go 5 to the right, 4 down. There's our vertex of this parabola. Because your a term, the term in front, is positive, we know it's going to open upward. And that's going to fit once we look at our x-intercepts, 7, 0, and 3, 0. And in fact, if we look at our y-intercept, 0, 21, it's going to be somewhere up here. That seems to fit the other points. So here is our general parabola. And, whoops, I should fix this side here, make it more like this. And there we go. So we know how to find our vertex, our x-intercepts, our y-intercept, and sketch this graph. Okay, let's try another one of these. So next problem, same directions. We want vertex, x-intercepts, y-intercepts, sketch the graph. Here's the function. Then it says by completing the square. Now why does it say this? Well, it says this because take a look at the form of this quadratic equation here. It's not in that standard form. So if I were to ask you right away, what's the vertex? Forget it. It's really hard to find. So we need to get it in that standard form. Well, I'm going to go back here. Standard form looks like this. Y equals something times x minus h squared plus or minus k. So we want this to look like y equals something times x minus or plus or minus something squared plus or minus k. So here's what we do to write it in standard form. We keep the x squared and the x term together for now. And we're going to separate things and bring this constant term outside. Okay, now I need to think in here, what number could I put in this spot to make what's in parentheses here a perfect square trinomial? Here's how I find that. I'd look at this value right here and take half of it. Half of this value is negative 2. Then we take negative 2 and square it, and that value is going to be positive 4. And we plug that right in here. Now the reason we do that is because what's in parentheses now can now be factored. Okay, it's a perfect square trinomial. We'll factor that in just a bit. Before we factor it though, I can't just go adding 4 wherever I want. My equation is now unbalanced. So over here on the right, I'm going to write minus 4. That keeps things balanced. Okay, net result is 0. So now back to factoring this. If we factor this, we would get x minus 2 times x minus 2, or x minus 2 squared. If we combine what's out here, we get minus 1. Now look what that did for us. Now our equation is in standard form. Okay, so now it looks like the equation on the previous example. From here, we know how to find the vertex, x-intercepts, y-intercept, and to sketch the graph. So I'm going to run through those things relatively quickly. Vertex is the point 2, negative 1. Your x-intercepts, I'm going to plug 0 in place of y. So I'm going to say 0 equals x minus 2 squared minus 1. I will add 1 to both sides. Take the square root of both sides. And that gives us 2 cases. If we add 2 to both sides, we get x equals 3, or we get x equals 1. So our x-intercepts, we have the 2 points, 3 comma 0, and 1 comma 0. And then last but not least, we have our y-intercept, which is if we plug 0 in place of x. If we do that, and we could actually do that up here or down here, we get, let's see here, if we plug 0 in place of x, we'll get a value of 3. Okay, so now let's jump to our graph. Vertex 2, negative 1. X-intercepts are at 3, 0, and 1, 0, and y-intercept is at 0, 3. Perfect. So there's our shape of our graph. Beautiful. Okay, so if we have our equation in standard form, we can jump in and find these answers. If it's not in standard form, we should get it in standard form first to find these answers. A couple warnings for you. First of all, we don't always have x-intercepts. So sometimes your parabola is up here above the x-axis. So if you get something here that can't be solved, that means you just don't have any x-intercepts. You will always have a y-intercept. Sometimes it's easier to find the y-intercept with the first equation rather than the second. Basically, these are just two different ways of writing the same equation. So really, we could plug 0 in place of x into either one of these. Same with the x-intercepts. Plug 0 in place of y into either one of these. Okay, let's take a look at another different kind of problem. So this one says identify the vertex, x-intercepts, y-intercepts, sketch the graph. It looks like the same kind of problem. There is something a little different with this one. We do need to complete the square. So I'm going to write y equals negative x squared minus 4x. I'm going to skip some space and put plus 21. Okay, now I'm emphasizing this problem because this is a very common mistake that students make. See this negative in front? If we have any value in front here, we have to factor it out first. We cannot complete the square until we've factored out this number, whether it's negative 1, whether it's 10, whether it's 2, whatever it happens to be. So we have to factor out that negative 1 first. We don't factor it out of everything, just out of those x terms, the x squared and the x term. So now we can complete the square. And I'm going to take a look at this 4. Half of 4 is 2. Square that, we get 4 plus 4. Now, here's a mistake people make. They write minus 4 over here. Careful. What we really just added is negative 1 times 4. We really just added a negative 4. To keep things balanced, we have to add a positive 4. Okay, now we're good to go. So y equals negative 1 times, if I factor this, I'd get x plus 2, quantity squared, plus 25. Now that it's in this standard form, we can jump right into our vertex. Our vertex is negative 2, comma 25. We can find our x-intercepts by plugging 0 in place of y. So I'm going to do that here. 0 equals negative 1 times all of this, plus 25. If we subtract 25, and then divide by -1. Then if I take the square root of both sides, we get 5 equals x plus 2, or -5 equals, let me clean that up, -5 equals x plus 2. Subtracting 2 from both sides, we get x equals 3, or x equals -7. So our x-intercepts are the points 3, 0, and -7, 0. Y-intercept, okay, to find this, we need to plug 0 in place of x. If we do that, and I'm going to do this in this first equation here, we get the number 21. Okay, so let's make a sketch of this graph. So my x and y axes, my vertex is the point -2, 25. So 2 to the left, 25 up. Y-intercept is 0, 21, so right about here. And our x-intercepts are 7 to the left and 3 to the right. So our parabola will look something like this. And it opens downward because of that negative in front of your x squared term, both up here and right here. Okay, so no matter what we're given, we should be able to complete the square. From there, find the vertex. We find our x-intercepts by plugging 0 in place of y. Find the y-intercepts by plugging 0 in place of x. Let's take a look at one last example. Now in this case, I'm giving you some information. Now we need to go backwards and find the equation of the parabola. Okay, so here's your vertex. Here's your point that it goes through. Now you did problems similar to this in Algebra 1, where you were given slope and a point and had to find the equation of a line. So if we take a look at our equation of a parabola in standard form, we need to plug in everything we know. Well, we know our vertex is h comma k. We also know this point is x comma y. So we can plug in everything. The only thing we don't know is this a right here. So let's figure out what that is. So plugging 4 in place of y, we get 4 equals a times 0 in place of x, -2 in place of h, and then 5 in place of k. Now let's do some algebra to clean this up. So 4 equals, let's see here, a times 2 squared plus 5. I'm going to square that 2 right away. Careful, it's not 2 times a with both of them squares, just a 2. So 4 equals a times 4 plus 5. Now here's a simple mistake that people make. People will say, oh, let's add the 4 and the 5. No, no, a times 4 is your order of operations. That's what you would do first. So instead, let's get rid of the 5. So that gives me -1 equals a times 4. And then dividing both sides by 4, we get, let's see here, we get -1/4 equals a. Well, that's perfect, but don't stop there. Let's plug our a value and our h and k into this standard form, which gives us y equals -1/4 times x plus 2 squared plus 5. So here's a parabola with vertex at -2, 5. It opens downward. We know the y-intercept. We could find the x-intercepts if we needed to, but all we need is this equation. Okay, that wraps up your notes on your first unit of Chapter 2. Here's your assignment, which is really those parts from our group work from the past couple days. So check this out, get this done, then move on to your second set of notes and assignments.